Greetings and welcome, friends. Yesterday we were talking about standard form of the equation of lines, and we will have multiple forms, not unlike transformers, and there will be multiple ways of representing equations of lines. And standard form looked like this. It is arguably the weakest of the forms of equations of lines, but it is beneficial for writing equations when given a word problem, a real-life situation. Oftentimes, you can write a standard form equation like so. However, the way we would graph these, the way we attempted was using intercepts method. But before we get there, let's talk about graphing the line y equals 2. And y equals 2 is going to be a line in which every point has 2 as its y coordinate. So imagine with me for a moment, go to a world in which every point has a y coordinate of 2. So that would be like 0, 2, and 1, 2, and over 5 up 2, and negative 1, 2, and negative pi 2. And every point, when they combine, I would have infinitely many of them that would form a line with horizontality, a horizontal line. I would put little arrows at the end of this because this line does not end. It goes on forever, my friends. And this would be a horizontal line that passes through, notice, 2 on the y-axis. So that's the way you might think about this. What's weird about these sometimes is thinking about the fact that here's the x-axis, here's the y-axis. The y-axis is vertical, but the equation of a line y equals 2 will give you a horizontal line. A little bit weird there. Oh, here we go. So this was the big idea from the lesson, was finding the X and Y intercepts. So to find the X intercept, I'm going to plug something in. I'm plugging in 0 for who, though? 0 for Y. Yeah, you would not have expected that. To find the x-intercept, the 0 goes in for y. I'll show you a graph in a later problem as to why that works out. But let's check this out. So I'd have negative 6x plus 9 times 0. I didn't even make you write that work, but for the sake of this homework video, I will write it down. 9 times 0 is 0, so that's just the same as negative 6x. And, right, this just is gone, right? But that's what happens. Fortunately, plugging in 0 is the easiest number to plug in, right, Amity? And so to solve for x, I'm going to divide both sides by negative 6. So I get x equals positive 3, because negative divided by negative is positive. Now, this is the same, all right? You would say your x-intercept is 3, but if you wanted to think about the point at which that is existing, that's at the point 3 comma 0, because remember the y coordinate was 0. Similarly, to find the intercept, the y int, I'm going to plug in 0 for who now? 0 for x. It's just the opposite of what you would think. And negative 6 times 0 plus 9y equals negative 18. Negative 6 times 0 is 0. That's just gone, friends. That went ghost. It will. We're getting there. We want our internet friends to catch up with us, though. To solve for y now, I divide both sides by 9. And I agree with Pooja that y equals negative 2. All right. That's fine. So here's our x-intercept and our y-intercept. Now, the reason that's helpful is sometimes you want to find out where those intersections occur, as we'll see with our word problem at the end. But also, those are excellent points for graphing with. Oh, man, that was excellent sound effects right there. Here, you guys can close your Chromebooks and your cell phones if you like. So for this equation, if I want to graph, we're going to use intercepts to graph. So I'm going to find, once again, the x-intercept by plugging in 0 for y. I'm going to cruise through this. Ready, guys? You got to hold on to your seats. So negative 2x plus 6 times 0 is 0. I don't even have to write that. That's equal to 18. Divide both sides by negative 2, neg 2. And I get y equals, nope, x equals negative 9. All right, so let's plot that on the graph. That's going to be x-axis is the horizontal one, negative 9 occurs over here. All right, so there's my x-intercept at negative 9, comma 0. Now to find the intercept, the y-int, we're going to plug in 0 for x. And notice if I plug in 0 for x, 2 times 0 is 0. That's just going to give me the equation 6y equals 18. Super easy to solve. And if I divide both sides by 6, I get y equals 3. Y equals 3. So as the y-intercept, that's going to be 3 on the y-axis. So that's 0, 3. Notice actually every point on the y-axis has 0 as its x-coordinate, right? Here's 0, 0, 0, 1, 0, negative 5, 0, negative 10, 0, 10. And that's one of the reasons why, to find the y-intercept, I plug in 0 for x, is that I'm finding the point that this line will have 0 as its x-coordinate, and the only possibility is going to be the y-intercept. So let's graph this line. So using just those 2 points, since this is a line, oh dear, undo, undoodly, undoubtedly, no. Okay, here we go. I can use any 2 points to make a line. That's a postulate you'll learn in geometria class. Geometry, friends. Geometria. And so there's my line, and now using those 2 points as a reference, every point on that line represents a solution of this equation. So, for instance, if I go, here's a point right here, we'll just pick one, 3, 4 by the looks of it. That's saying that 3 and 4, when plugged in for x and y, should make this equation true. Let's just do a little quick check-see on that. Why not? We haven't done that before. 3, 4, if I do negative 2 times 3 plus 6 times 4, is that going to equal 18? That's negative 6 plus 24 equals 18. I write negative 18. 18 equals 18. It's true. It's true. And not only do the integers on this line work, but so do all of the fractions and all of the irrational numbers. So there's infinitely many points on this line, and that line represents the solutions of this equation. So that's the relationship between the equation and the line. Let's do the word problem, friends. I think I picked 24. Ooh, you were ordering shirts for the math club at your school. Represent. Man, short sleeves cost $10 each. Long sleeves cost $12 each. You have a budget of $300 for the shirts. And look at this, they conveniently gave us the equation. Eventually, you and I will be writing our own equations based off these word problems, right, Amity? That's right, Mr. Waddy. And so check this, then they tell me some facts that this equation, 10x plus 12y equals 300, right, models the total cost, where x is the number of short-sleeved shirts. That's alliteration, friends. And y, the output, is the number of long-sleeved shirts. All right, so this is LSS, long-sleeve shirts, and this is SSS, short-sleeve shirts. Bam. And I'm going to now find a graph of this. So my equation is 10x plus 12y equals 300. If I want to find the x and y intercept, because that right now, besides making a table of values, that is the only way I know how to graph. To find the x intercept, we plug in 0 for y. If the 0's right there, then 12 times 0 is 0, and adding 0 is nothing. Feel free to use that artist in any of your albums. You can take that audio clip, no rights reserved. Like, you just add that, like make some sort of cool digitized sound effect from my little song, and anytime you can use that. Fine, it's fine. Yeah, featuring, yeah, B Watts. So let's see, looks like x equals 30. So let's plot that point. Hey, it's almost like I planned this coordinate plane for this problem. So I get x equals 30. Let's find the y-intercept. Running out of space here. The intercept, I'm going to plug in 0 for x, right? And if I plug in 0 for x, 10 times 0 is 0, adding 0 to 12y, that's just 12y. Are you getting this, friends? If I gave you a mini quiz right now, would you be solid on being able to graph using the intercepts method? No, I'm hearing no. Okay. Well, yes. I'm hearing a yes. All right, let's see. For some reason, I'm not confident about 300 divided by 12, but it's 25. Yeah, I think, yeah, the reducing idea is a good idea. Yeah, like 6 goes into both, and yeah, keep going. So let's see, let's plot that point. So there's 25 on the y-axis. Let's draw this line. And remember, this line represents all combinations of spending my $300 on shirts. Now, I'm going to restrict the domain and range to being positive, okay? I'm not going to let this go negative, because that would represent a situation in which I sold them a short sleeve shirt that I made myself so that I could buy an extra long sleeve shirt or something like that. That just doesn't make sense. Like, this business isn't going to be like, we don't want your bootleg t-shirts, Mr. Waddy. We sell shirts. You're buying them from us. We are not buying them from you. So negative numbers of short-sleeved shirts purchased it doesn't make sense in the context of this problem. Let's see. So this is going to be the same as going. Let's see. We want to find. All right. It said. Let's interpret these solutions first of all. Slow down, Waddy. So this is 30, 0. That is the situation in which I spend $300 on 30 short sleeve shirts, and how many long sleeves did I buy? 0. I didn't buy none. Okay? And this situation was 0, 25. This is if I was to say buy 25 long sleeve shirts, spending all 300 of my dollars, and having no money left over for short sleeves. But don't worry, Math Club. You can all just, like, tear off those long sleeves summertime, and we'll just go, like, you know, tank top style math shirts. It'll be awesome. Rip the sleeves off. We'll do that at the end of, like, our first Math Club, like, team victory. We'll just, like, yeah, we'll show our math biceps. It'll be great. It'll be great. So anyways, they then asked me to find different amounts of shirts that can order. So they said 12 students decide they want short sleeve shirts. So if I go over to 12 and I go up to my graph, how many long sleeve shirts can I buy? Over 12. What's the y coordinate of this point? Bing, 15. 15. So you find the input you wanted, and then you read it up to the graph, and then you go over to find the output, right? So 12, 15. So that means, yeah, that if 12 buy short sleeve shirts, then I can buy 15 long sleeves, etc. Also, I can find other solutions. It looks like this is a solution. It's kind of hard to read exactly where these cross the line, but I could buy 6 and 20. I could buy, I think I could buy this amount. What's that going to be? That looks like 18 over 18, and it looks like 10. So 18 short sleeve, 10 long sleeve is a combo. I think this one's a combo right here. This looks like it's 24 short sleeve and 5 long sleeve. All right. Question, yeah. Yeah? Yeah. Oh, dude. I almost want you to teach today's lesson, friend. But thanks for watching, Internet friends. He's right. There is a pattern there. I was kind of cheating with finding those points so quick. I let the mystery be revealed without being spoiled. Bye-bye.